Hey folks, welcome back. Today we're going to talk about energy and stoichiometry. Stoichiometry, your favorite thing? So we're going to talk about how that relates to energy. Where does the energy go in a chemical reaction? Now we've already talked about what delta H is, and we've already talked about that when you see a negative delta H, this is propane burning. Whenever you see a negative delta H, that means it's exothermic. So if we were to rewrite this, we would say plus 2200 kilojoules over here on the right, because this is something where you are generating heat, you are creating energy. So if I was over here and I was cooking my turkey on Thanksgiving, then we would be generating a lot of heat in the propane burner underneath the oil that's this turkey is about to go into, right? And if you've never had fried turkey, darn good stuff. You should try it. Love it. All right. Remember, there is never negative energy. All right. So even though our delta H is negative or positive, what the sign is telling us is where to put the energy. So when we see propane burning, the negative delta H tells us that we are producing energy, and we're going to say plus 2200 kilojoules over here. But when we see a positive delta H, that means it's endothermic. So we would say we have to put heat into this. So this would be plus 15.9 kilojoules of energy. So we would put the kilojoules of energy over there. So all that the negative and positive sign is telling us is where to put our energy, whether it is exothermic or endothermic. So you need to be able to figure that out just by looking at the delta H in the equation. All right, so here's an example of propane burning. And here's the question. If 12.4 grams of propane react, in other words, they burn, how much energy is produced? Well, when you see grams here, you know what to do with 12.4 grams of something, don't you? Of course, you have to go to moles. Now, what you'll notice here is that 1 mole of C3H8 produces 2200 kilojoules of energy. Okay, so 1 mole of C3H8, that's a 1. Right, produces 2200 kilojoules of energy. So we're just treating this like any other stoichiometry problem. Right, so the first thing we have to do is figure out how much C3H8 weighs. So that's 12.011. We multiply that by 3, and we add it to 1.0079, and we multiply that by 8. Right, I've already done that for you, and that's 36. 24, 36. That's not right. That's 44. 44.096 grams per mole. All right, so let's use that information. So we actually have a very simple stoichiometry problem where we have 12.4 grams of C3H8, and that means we have to get rid of grams of C3H8. Remember, we always start with the information we're given. So grams of C3H8 go on the bottom, and what we want to go to are moles of C3H8. So moles of C3H8. And 1 mole of C3H8 weighs 44.096 grams. Are we done? No, because we're asking how much energy is produced. So now we have the piece of this that relates to energy. And 1 mole of C3H8, 1 mole of C3H8 produces this many kilojoules of energy. So 2200 kilojoules of energy. So all we have to do is multiply this out. So we take 12.4, we divide by 44.096, we multiply by 2200 kilojoules of energy, and this is going to give us 619 kilojoules of energy. Now we only see 2 sig figs up here in our problem, so we're going to say that that is 620 kilojoules of energy, and that's our final answer. All right. Go ahead and pause the video, see if you can work this one out. It's exactly the same concept. Remember, we don't worry about whether the kilojoules are positive or negative. All we do is focus on which side of the reaction they are, of whether they're consumed or produced. All right, so we're starting with 19.2 grams of sodium bicarbonate. That's this thing. So we better figure out how much sodium bicarbonate weighs. So sodium is 22.99. Hydrogen's 1.0079. Carbon is 12.011, and oxygen, there are 3 of them, so that's 48. We're going to add all those up, and that's going to give us a total mass of 84 0.009 grams per mole for sodium bicarbonate. All right, did you get that far? Hopefully. Now we start with 19.2 grams of sodium bicarbonate, NaHCO3. Now we have to go from grams of sodium bicarbonate, NaHCO3, to moles of sodium bicarbonate, NaHCO3. I'm not done because I'm trying to figure out energy. Energy is here. And I have a relationship between this much energy and 1 mole of sodium bicarbonate. So if I go from moles of sodium bicarbonate, NaHCO3, to energy, which is in kilojoules, I have 15.9 kilojoules are going to be consumed for 1 mole of sodium bicarbonate. And 1 mole of sodium bicarbonate weighs 84.098, sorry, that's not right, 84.009 grams per mole. So if I divide out and multiply, I get 3.63 kilojoules of energy. 3.63 kilojoules of energy. Okay, that's pretty simple. All right, we've got one more. The delta H for the combustion of hexane is negative 8,326 kilojoules. How many grams of carbon dioxide is produced when we have that much energy released? Okay, pause the video and see if you know what to do. All right, did you come up with the balanced chemical reaction? If you didn't do the balanced chemical reaction, pause the video, come up with a balanced chemical reaction before you keep going. All right, let's go ahead and do our balanced chemical reaction. We have hexane, which is C6H14, plus oxygen, is going to give us carbon dioxide and water. All right, so if I have 6 carbons over here, I put a 6 there. I have 14 hydrogens, that means I put a 7 over here, and I have to have O2s. Well, that gives me 6 O2s, and that gives me, oh gosh, 3.5 O2s. I've got a problem, so I'm going to go back and multiply everything by 2. So I'm going to multiply that by 2, which gives me 12 carbon dioxides, and that gives me 14 waters, and that means I've got 12 O2s here and 7 O2s here. That gives me a total of 19 O2s there. And how much energy? Oh, well, this is exothermic. You'll notice it's a negative kilojoules, so we're producing energy, so we're going to put the energy over here, 8326 kilojoules of energy in this reaction. Okay, so let's see what we have. We have how many grams of carbon dioxide are produced when we have this many kilojoules of energy released. All right, well, notice that we actually have 2 moles of hexane. That's cool. Doesn't matter. We have a balanced chemical reaction. We've been given what we need to know, and we're going to go and work this thing out. So we're going to start with the information we're given. So again, if you didn't get this far, pause the video and see if you can work this one out. Okay, so we start with 15.99. That's not even close. 1566 kilojoules of energy. Right? And what do I have to do? Well, I treat this like any other stoichiometry problem. I'm starting with kilojoules, so what goes on the bottom? Well, it has to be kilojoules. Right? And my kilojoules are 8326. Remember, now guys, you can do this negative. It really doesn't matter, but there's no reason to worry about the stupid negative sign. We know that this is an exothermic reaction because our delta H is negative. So we know we have to produce energy. We're going to produce positive energy, so just make it positive. Okay, we have to go from kilojoules. And what are we going to? Well, we're going this many kilojoules for 12 moles of carbon dioxide. It's 12 moles of carbon dioxide. But we don't want moles of carbon dioxide. We want grams of carbon dioxide. So I have to figure out how much carbon dioxide weighs, that's CO2. And if I figure out how much carbon dioxide weighs, that's 44.011 grams of carbon dioxide. Okay, so that's 44.011 grams of carbon dioxide per 1 mole. Per 1 mole. All right, so I'm good. So I have 1566 times 12 times 44 divided by 8,326. This gives me 99.33 grams of CO2. All right, I think we're done. If you have questions, please see one of us in class. We'll be more than happy to help you. Have a great day. Take care. Bye-bye.